Welcome back. Welcome to part 14 of our workshop. And in this part, what I want to do is I want to implement some pseudo instructions. So they're not instructions we'll find here in the instruction set, but they will make our life a whole lot easier when we are writing our assembly code. So there are a handful that I want to do. I want to do 4 in this episode, and then I want to save the last one for the final episode because it'll be a little bit more involved. The 4 that I want to implement in this episode are DW, DS, org, and end. So DW allows us to place a 16-bit word anywhere we want in our assembly, in our program. DS allows us to reserve a space for uninitialized memory. Org is a way to force update the address counter. This is used all the time in CPM assembly. Almost all CPM assembly begins with the instruction org 0x100 because that's the entry point for CPM programs. And then end just says, if there's anything after this, too bad, we're at the end of our assembly. So let's start with end because that's the easiest one that there is. So end is simply the end of the assembly. End of assembly. Even if there is more code after. So if you write an end, that's it. Our assembler is just going to up and stop itself. And so this one, interestingly enough, is the one special case in terms of arguments. This one actually needs the input as well. We're going to see why in a second. So end should not have anything. It shouldn't have a label. It shouldn't have a first argument, and it should not have a second argument. And all we need to do is set the line counter to the largest possible number that it could be. And so numbers in D have properties like min and max. Max is going to be the largest number that an input line can hold, which if we go all the way back up to our input class, that's an unsigned long. So that's going to be a really, really huge number. So big that there's no way you're going to ever be able to write anything that is of that size. So all we have to do is say input line max, and I'll say -1, just so that it increments and is a number far larger than you could possibly have written in your code, and that way things just end. And that's it. That takes care of end for us. So the next one I want to do is org. And so like I said, org for us is going to force update the address counter. Again, it's used all the time in CPM assembly coding. Everything begins with like org hex 100. So at this point, we kind of know our boilerplate, tokens, output. And what do we need to check? So org only takes one argument. So we'll say tokens. Org should also not take a label. So we'll just say if label is empty and we have an argument for our first argument and we have an empty second argument. All right, so what are we going to do? We're going to take a number and we're going to force update the address counter to be that number. And we're only going to worry about numbers. We're not going to worry about if you give a label as an argument to org. If that's a thing you want to implement as you are further developing your assembler, you are welcome to do that. But I'm not going to do that. I'm just going to worry about if they are numbers. So if it's a number, and if we are in our first pass, then let's just force update the address counter. Kind of the same thing that we did with numbers, right? We're going to check to see if the first character in our number is a $sign. If it is, we want to make sure that we make it into a hex number. Otherwise, it's just a decimal number. All right. Otherwise, if for some reason we don't have a number, let's just error out. And we'll say, org requires a number for its argument. That way the user knows what they did wrong. And that takes care of org for us. Now we can kind of be more precise about exactly the memory layout that we want for our programs. All right, the next one that I want to implement is DW, and DW is going to place a 16-bit word wherever we happen to write the DW instruction. So we'll just say place a word. We'll say void DW, tokens, and output. And so same thing. DW should only have one argument. So if we're on the first pass, we still do need to check to make sure that if there's a label on that line, you can put a label on a DW line. So we'll just want to make sure to check for that. Again, the logic is the same as we've done in the past. And then we want to take the address. We always want to increment by 2. And we're done. Pretty straightforward. All right, and then the last one I want to do for today is going to be DS. And what DS is going to do is kind of reserve space for us. Oh, hold on. This should be... There we go. We don't want to spit out, right? Because if we remember, address will... There we go. Address. If we're in pass 2 of address, we're going to spit out. Actually, address will take care of that for us. Let's not even worry about that. Let's make our lives a little bit easier. Let's actually just get rid of that. And we'll just stick address like that. Because it won't spit out any values unless we're in the second pass. But we do always want to make sure to increment by 2. That's important. All right, lastly, like I said, DS. So DS is going to reserve an area of uninitialized memory. So again, boilerplate, tokens, output. All right. So actually, let's make this bigger. Let's make this a ushort. Why not? There's no reason we can't take out more than 256 bytes. So let's make it a ushort. So let's check. So we only want DS to have a single argument. And so same thing. If we have a digit, or we have a $sign, and I think we all know what we're going to do here. We'll set value to be either hexadecimal or decimal, depending on what we have. Or without the $sign, then it's just decimal. Otherwise, we have an error. And just let the user know DS requires a number, so you got to give it a number. If we're in our first pass, we do need to update the amount of space that we actually reserved. We also need to check if we have a label, because we can in fact still have a label here. So if we have a label, we'll have to add it to our symbol table. Otherwise, we increment address by the value. If we're in pass 2, we write out that number of zeros. into our binary. And that's it for DS. So we can now place any value we want anywhere in our program, by 16-bit words. We can reserve as much space as we want in our programs. We can update the address counter, so it'd be very helpful if we write CP/M programs, or we can just end assembly. There is one pseudo instruction that we have left, which is going to be how we place a byte, which will be our DB instruction. And because this one will require a little bit more work, we're going to save it here, and we're going to have our final episode be implementing DB. So we'll say implement DW, DS, org, and end. All right, join me in our last episode.